To evaluate this integral, I'm going to need to reverse the chain rule. So I would like 2x plus 1 to the 3. If I originally had that, I would have a power 4 up here, and that would bring a 4 down the front to derive it. So ideally, I would have a 4 there. If I had a 4 there, I can put a quarter out the front that's going to balance that off. The other thing is, if I were deriving and it had a power of 4 up the top, I would have needed to also times by my inner derivative, and I should have a 2 out the front. So I'm going to put a 2 out the front as well. Then I'm going to need to put a 2 out the bottom, out the very front, to balance that off. Now I know that were that the case, I would have had 2x plus 1 to the 4. That would actually derive to 8 lots of 2x plus 1 to the 3 because of the 4 coming out the front and the 2 also coming out the front. But I've balanced that over here, so I'm going to have to put my 1 on 8 out the front, my 0 and my 1 over here to make the integral. Then I can do my substitution, keep my 1 on 8 out the front, sub a 1 in, so I'm going to have 2 lots of 1 plus 1, so that's 3 to the power of 4, minus 2 lots of 0 is 0 plus 1, so 1 to the 4, which would equal 3 to the 4 minus 1 on 8, which is equal to 3 to the 4, I think that's 81 minus 1. 3 to the power of 4 minus 1 makes 80, so 80 on 8, which is 10.